I think we will be starting shortly. I would like to extend our warm welcome on behalf of experts of this webinar to the participants that are slowly joining us at the moment. For those who has joined us a little bit earlier, you had a wonderful insight to our chat about the beauty of city of Istanbul. And we are really looking forward to start. I will just slowly move to the official part of this meeting and introduce the project and why are we here today, and then give the floor to the experts that are joining us. So in general, we are meeting here today at this webinar to look at the issues related to how to teach in an innovative way, having in mind the resource consumption and circularity with that can be combined with looking into energy system and looking into new ways to support the transition towards sustainable energy practices. And this is basically at the core of the CESynergy project that we have a pleasure to present to you all today. And having said that, I have with me wonderful experts, Dr. Selcuk Toprak, Professor Marta Alves, and Professor Krzysztof Pikoń from the universities that I will shortly introduce that are also the project partners. So in general, the consortium is consisting of renowned universities, University of Bremen from Germany, the University of Lisbon from Portugal, and we have Professor Marta Alves from this university represented today, and Gebze Technical University that is based in Turkey, and we have Dr. Selcuk Toprak. And in general, we also have INNOWO, that is Polish Institute for Sustainable Development and Innovation, and we have Training 2000 from Italy. And in general, the idea here is to make sure that together with all the partners and this Silesian University of Technology that Professor Krzysztof Pikoń is representing, we will be able to brainstorm and share the ideas about the future ahead related to transformation of energy systems. So without any further ado, I would love to pass the floor to our experts and have in mind that the time is yours. You are free to ask questions during the presentations. And we will also have a couple of minutes towards the end to do some exchanges and maybe also hear from you. In general, the setup is that we have 1.5 hours, which means that we have just started 2 minutes ago, and we will have time till 12 p.m. For this time together. So without any further ado, dear experts, the floor is yours.
Thank you very much for that. Perhaps I could start, and perhaps I could, in brief, present our project. I will share the screen now. Yep, and probably you can see it. Right? Can you see?
Yes.
Okay, so just a few words about our project, which we are conducting together. Thank you, Grażyna, for this kind introduction. I will start with a motivation. One, why we have started to talk about circularity in the power systems. Well, we are currently in a process of energy transition. So we would like to move from fossil-based to renewable-based sources of energy. And the main objective, of course, is decarbonization. If we look at this slide, and if we look at the data, well, this tool that we are using, I mean renewable sources of energy, it's quite effective. We are emitting much less greenhouse gases from renewable sources than from fossil-based. And additionally, we are using much less materials for renewables comparing with fossils. Well, it's quite obvious. But looking critically at that, If we look at how valuable sources of materials we are using to build installations based on renewable energy, we can find out that they are much worse looking from this perspective than fossil-based, which is perhaps a shock for many people. But for instance, solar energy would have environmental impact in abiotic depletion impact category even 4 times higher than energy coming from coal. Which means that without the proper implementation of material management, without the proper implementation of circularity, well, energy transition and reduction of greenhouse gases emission is simply not possible. And this is the main motivation for us for this project. Why? Because we have identified a huge gap in teaching process and in teaching materials, in programs, in courses in different universities. While talking about decarbonization, while talking about energy transition, we are not emphasizing strong enough this material side, and this gap we are trying to fill in our project. Finally, we will develop two major outputs. The first one is e-learning course. It will consist of three modules, and additionally, we will develop a compendium, which will be a publication, something like a policy paper, together with some practical information about the scope of the project. All those materials will be available in 6 languages, and of course it will be available for free for everyone, because it's a European project. If we look what will be inside this e-learning course, I have mentioned three modules. Module number 1, it will be a general introduction to the issues related to circular economy, environmental impact assessment, and material use and abiotic resources depletion. In module number 2, we will collect some the challenges for students, because we believe in challenge-driven education as the most effective. We'll discuss it later on. In module number 3, we'll explore different aspects of circularity in energy transition process. We would like to be also innovative in the form of delivery, because we will implement very modern and very effective teaching tools on this e-learning platform. We will also deliver the whole structure of learning outcomes, ECTS recommendation, and pedagogical methods that could be used together with our learning materials. Some other novelty, we would like to develop our modules in our e-learning in a form of small nuggets. It will be a nugget structure. Why? Because it will be very easy for other teachers to use those materials. So the whole modules would be divided into short nuggets that could take something like 15 minutes for delivery, covering the specific issues important to our general concept of circularity in energy transition. It's very modern form. It is flexible, and it is very effective. We would like to have the highest possible impact. That's why we are trying to develop it in that way. The second big result of our project will be compendium, where readers would find a practical educational materials for resource on circularity, and also some case studies, policy examples, and technical indicators. The target of our project and the target for all those materials that we will develop, well, it is of course students, of course professors at universities that could freely use this material developed in our project in their teaching, in their courses. But also it could be used by policymakers, administration, and energy companies, and sustainability officers in different public bodies. Well, as I mentioned, it will be available to everyone in 6 languages. So I think it could be very interesting material for all those target groups to be used in their everyday activity. And finally, I would like to emphasize once again that without proper implementation of principles of circular economy, energy transformation, energy transition would not be possible in the future. We'll just run out of resources. So it is extremely important to teach our students that implementation of circularity in energy transition is a must. It is not just an option. It's a must. If anyone is interested in our project, we have a very nice web page, CESynergy. Well, you could go there and see all progress in our projects, and when delivered, we will also publish results, I mean those teaching materials, on this web page as well. If you would have any questions regarding the project, please contact us. We would be more than happy to answer all questions. And from my side, that's it about circular economy pathways for energy transition. So our project, which together we are developing. Okay, thank you for that. And now I would like to move to the second part. This is the part when experts will deliver their presentations. So now I would like to share my screen, of course.
So thank you so much for wearing double hat for today's meeting, when you are not only introducing the project, but also introducing the content for the further discussion.
Yeah, okay. Can you see my presentation now?
Not yet.
Not yet.
This is why I
okay.
inserted myself in the conversation.
Yeah.
It's coming.
We can see it now.
We can see, yeah, that's good. That's good. So I will start from the beginning, because previously that was the middle of my presentation. So each year reports on circularity gap are being presented, and those circularity gap reports are showing how much advanced in implementation of circular economy we are. Here you have a circularity gap report for Poland, but those reports are being presented for the whole world and for different countries. And in the latest report, I have found that, well, on one hand, we are talking about circularity. So the circular economy term is being used very widely. So the volume of different discussions, debates, articles is rising. It rose 3 times in the last 5 years, 3 times. But at the same time, the circularity index is going down by 21% in the same period of time. And actually, in addition, the global consumption of materials is accelerating. Imagine that only in 5 years we used 28% of all materials that our civilization used since beginning of 20th century. It shows how quickly we are using resources, and this pace is going up. At the same time, circularity is going down, and but the talking about circularity is 3 times higher than 5 years ago. So we are talking, but we are not doing much. This is a major conclusion from this report. So it shows that we should accelerate our efforts towards implementation of circular economy. And the problem that we are having currently is quite high, because if we look critically at different segments, different parts of our economy, we could conclude that, for instance, if we are talking about mobility, well, our cars are standing in parking places for 92%. So imagine if we would change this index, and if it would be 50% of leisure time for our cars and parking places, we would need just 50% of the cars that we are using now. So we have huge reserves. And on the other hand, we have a huge challenge. As the construction is concerned, well, our offices are generally occupied only roughly in 50%, and in a European scale, 11 million houses are empty, and we are still building new. So, as you can see, we need some change in concept. We need to implement something new, different way of thinking, new, different approach. And if we look at the material flow in the European economy, we will notice that our index of recycling, well, it is roughly 12% only. So we are, we could say that this is much, but on the other hand, we could say that there is still very long distance to be covered, because 12 is high, but on the other hand, we have 88% to complete, to go. If we look at this diagram, you will notice that we are losing materials in a high extent due to emission to air, and the source is combustion of fossil fuels. So this is this first meeting point of circular economy ambitions and energy transition. This is why we are focused on energy transition as well while talking about the material flow, because the majority of losses in materials are due to combustion. So we decided to change our energy mix. So as you can see, in time perspective to year 2050, we would rely on nuclear and on renewable sources only. We would like to get rid of fossil fuels totally. So those trends are obvious, they are published, and they are more or less accepted. But I would like to continue thought that I have started during my first presentation. Well, because I told you that we are using much less materials, but the total environmental impact in abiotic depletion impact category is higher. Why? We can try to recalculate the use of different materials into the equivalent substance, exactly the same as we are doing for decarbonization. So we could recalculate emissions of other greenhouse gases to CO2 equivalent, giving one equivalent emission of CO2. We can do something very similar, taking into the consideration how valuable from environmental point of view are different substances, and we could try to recalculate it to the antimony equivalent. So very similar process. And if we would compare renewable sources of energy and non-renewable sources of energy, fossil-based, well, this is the left side of the screen. What we can notice that the CO2 equivalent emission for energy coming from lignite, from coal, from oil, from natural gas is much, much higher than coming from renewable sources of energy. Of course, renewable sources of energy are not zero emission because we should look from the LCA, so the whole life cycle perspective. But if you look at the right side of the screen, you will notice something completely different. So vice versa. Wind energy and solar energy, environmental impact. So this use of abiotic equivalent is much higher for wind and for solar than from coal. So this is this problem, this is this challenge that is ahead the technologies and this is a challenge for our civilization now. If we would like to implement circular, if we would like to implement energy transition, circularity is simply the must, because we are using less materials, but much more valuable materials for renewable sources of energy. And how the projection for the next years looks like. According to European Commission documents, well, the projection for year 2050 is, as you can see, for lithium, we will multiply by 21 our use of lithium. In case of graphite, it will be 26 times. In case of nickel, it would be 16 times. And in case of platinum, 200 times. So renewable sources of energy are based on non-renewable materials. We have on planet Earth, we have a very limited number of limited volume of those substances. So this is not question if, but the question when we run out of those resources. It shows how critical situation will be in the future. It is not now. It is still not now. The supply of those materials is on a good enough level, but in the future we will have a huge problem, and in the future someone should solve this problem. That's why our students should be aware of it and try to think in a little bit different way. But while talking about critical raw materials, and if we look also from the geopolitics point of view, well, the main supplier of critical raw materials currently is China. It happened 1 month ago when China put some restrictions on export of critical raw materials, and the projection is that perhaps in 2 months, this is quite short time perspective, the automotive industry in Europe would have a huge problem. Perhaps the production of some cars would be stopped if this problem with export of critical raw materials from China would not be solved. So circularity, this is also material safety, security for EU. What circular economy is, perhaps you know this definition. In general, it is increase of prosperity while reducing and optimizing resource consumption. Our objective is to make further optimization, but I would like to underline that this is not just about the better waste management. This is a different way of thinking, different way of using different things. This is also the issue of completely different design. So circularity is starting at the very beginning of the process of production of anything. So on the idea stage. We have an idea, then we are planning, then we are starting preparation to production. So it starts really early, and actually this is another issue that should be represented in teaching materials currently. So this is not just waste management, not just the optimization of process, not just the reduction of use, but completely shift in our approach. So our economy should be regenerative by design. This diagram is very popular. It shows that we could implement circular economy concept on different stages. This recycling is the last one, but we should include also refurbish. We should reuse. We should extend the life of different products. We should be focused on better maintenance of them and different use. The ultimate goal is to reduce the leakage from the system 100%. It will be very hard to be reached, but if we cannot do everything at once, it doesn't mean that we should not follow that we should go in that direction. So this is a huge process, long-lasting process, but as I said, it's absolutely must. So we have different tools. One example is a resolve framework, and we could be focused on regenerate. So, for instance, shift to renewable energy and materials. It could be reclaim, retain, and restore health of ecosystems. So regenerate, share. So moving to sharing economy. Do we need a car? Do you really need to possess a car, or you need to secure transportation from point A to point B? So we could share some elements which currently are our own. So do we really to own a car? Do we really need to own some goods, or we could share it with others? So sharing economy, of course, extended life cycle, optimization, closing loops on different levels. For instance, remanufacturing of different products. And virtualization. This is what we are doing now. Imagine what would be the material and carbon footprint if all of us would like to go together in one place. Emission from transportation would fly. We should book a hotel. We should use a public transportation. Going to the place where the meeting is organized. So comparing to the virtual to the virtual option, well, the environmental impact is much lower. So virtualization in many places is delivering really good benefits. And exchange. So select appropriate resources and technologies. So we have some tools, we have some good concepts that is described in a good way, but we have also some regulations, we have a directive, we have circular economy action plan, and the main message is that without proper implementation of principles of circular economy, energy transition is not feasible in long term. That's why our project is trying to equip educators, students, decision makers with tools, knowledge, and strategies to make circularity a core pillar of the energy transition. Well, as I mentioned at the very beginning, we have identified a gap. We have made some surveys. We have had a lot of discussions. We have screened a lot of teaching programs, and finally, we have identified a gap in educational system. I mean that there is number one, lack of integration of circular economy concept into energy-related curriculum. It is, of course, circular economy is now present in a curricula of different universities, but there is still lack of connection of energy and circular solutions. So we believe that it should be fixed, and we are trying to deliver it by delivering those small nuggets that could be implemented in teaching of circular economy programs and also energy related programs. We have also identified a gap in insufficient interdisciplinary perspective. So we should be more focused on connection of different fields. Also limited use of active and challenge-based learning methods. As I told you, our project is also focused on innovative education, which means that we are not trying to promote this traditional way of teaching, so lectures, some exercises and stuff like that. We would like to be more focus on active education and especially challenge-based education. So if we would like to be more effective in the future in teaching our students, we should move to the challenge-based methods more extensively. And something similar, something connected with the previous point. Teaching on real examples, so practical education materials showing practical implementation and real examples. Why it is important? This is what I'm trying to say from the very beginning. The future of power system is based on renewables, and renewables are based on non-renewable critical raw material sources. So this problem should be solved. Key educational goals, because we are talking about education. Understanding material and energy flows in energy systems. We should be more focused on life cycle system thinking, not just looking at the one stage of life cycle, and designing solutions based on circular principles, perhaps in a result framework or others. The new international standard was already developed. So circularity will be measured in all companies in the future, and it will be an obligation in ESG reporting. So where it could be integrated in engineering courses, of course, but also in architecture, in planning, in policy management programs, and other interdisciplinary modules. So not just the education in technical universities, but also in others. Those competencies that should be developed, that should be strengthened, is competencies in life cycle thinking, is system thinking, in circular metrics and tools, and also in eco-design and innovation, also industry and circularity, and of course, decision making. Why it is so crucial? It is so crucial because of those connections, because of this material connection between circularity and energy transition. I'm running out of time, but I'm close to the end. Of course, we have some regulatory issues. We have some already developed documents. I think that the number of these documents and requirements would be higher, which means that we should prepare our students for that. So this is also the gap that should be filled. It is not filled good enough in current teaching. So we should emphasize it in future teaching as well. And of course, we would like to, and it must be done to culture game changers. Our students should be out of the box. They should not just follow already design solutions, but they should try to develop something different, which means that new pedagogical models should be used, mainly based on a real example. So we could use a project-based learning, challenge-driven education, but also innovative methods like a flipped classroom. We should implement some gamification and data-driven aspects. So the key learning implementations would be address real challenges, better understanding of life cycle, develop interdisciplinary skills, and prepare new roles in sustainable innovation, because we should try to prepare our students not for the current labor market, but for the future labor market. So going to the conclusions. Number one, circular economy is a critical enabler of sustainable energy transition. Number two, energy education must evolve because currently we have identified huge gaps, and it should be better prepared in a better way for the future challenges. So new skills and competencies should be implemented. And of course, we should remember that education plays a significant role in shaping of the future. And issues related to circular economy should be successfully implemented in different programs from different fields. Yeah, I'm almost on time. Thank you for your attention. If you would have any questions later on, I would be happy to answer. Thank you. We cannot hear you.
So maybe should I step in?
Yeah, I think
well,
so. Yeah, please.
I will be the next presenter. Thank you very much for this kind invitation. It is a pleasure to share some of my knowledge here with you all. And I hope that you are seeing my presentation in full mode. Can you confirm, please? Yes,
Yes,
Marta. Thank you very much.
Yeah.
Thank you. So I'm talking about the innovative teaching methods for energy transition in the same line of what was presented before, involving the landscape of energy education and preparing for future challenges in sustainable world. As already presented in the early beginning, I'm Marta Alves, an auxiliary professor from the Chemical Engineering Department from Instituto Superior Técnico under the umbrella of University of Lisbon. So again, innovative teaching methods for energy transition. Why? Because we need to take some attention to climate changes, to energy insecurity, and sustainability goals demanding rapid transformation. So to ensure that we have a prospective future where we can still have a good life condition. The challenge, current educators struggle to keep the pace with the interdisciplinarity and technology shifts. And we should account for this in the teaching methods that we need to present and in the curricula. But we have challenges, also we have new opportunities. We need to give new generation of students with new thinking and technical skills. So we need to introduce in education real world challenges and to provide policy collaboration and do a short roadmap for impactful energy education. So because you are going to be the future, we need to guide you through it. The evolving landscape of energy education, we need to provide skills and competencies for future energy transition professionals in several stages of the energy transitions that go from developing the systems, integrating the materials, and so on. Addressing these by critical interdisciplinary challenges in teaching energy transition. And this should come from the new curriculum in chemical engineering and specific energy courses that we are teaching in our universities, and where we aim to implement some of those. About the sustainable principles, we, as already mentioned, need to reduce emissions. We should go for renewable sources. Whatsoever, we should account for cost effectiveness, because we might find a wonderful solution, but if it's not cost effective, it will not be implemented. We should account for ethical sourcing and minimal social harm. With this said, there are many children being explored to provide some mineral sources so that we can feel good in our houses and have electrical cars. So we should account for this as well. And we should also account for the environmental impact. We know that renewables have a lower impact than fossil fuels whatsoever. Renewables are intermittent, they depend on the weather, they depend on the time of the day. So we need to store energy. This is a crucial development to ensure that renewables are feasible. And for those, we need materials for energy storage devices. And traditional materials for energy storage devices like batteries and supercaps, they have high environmental costs and they have limited availability. So we need sustainable alternatives. And for those, we need integrative knowledge of the energy systems. We need to understand the energy system as a whole. We need to bridge technical and socio-economical aspects. And we need to provide it in the pedagogical innovation. We need to do it active learning, problem-based learning, and experimental teaching, and use digital tools and virtual labs in energy education. Bridging the science and practice in energy education is essential. Engage with scientific developments and with practical tools. And in this part, I'm involved in several projects that are devoted to find new and sustainable materials for energy storage devices. On your left-hand side, you have an energy storage device, for instance, like a battery, and the main materials for these devices that define the electrical metrics are cathodes and anodes, the electrodes. And for those, we need really, really important materials and sustainable materials. One of the projects that I'm involved in is to use quark-based electrodes, and this can be driven from the quark industry, where the leftovers can be recycled towards the design of electrodes. Also, separators, other important aspect of the devices, they can be built up on cellulose-based membranes so that they can be recyclable. For the electrolytes, we can expand the performance window of these devices by using ionic liquid derived from bio-based precursors so that we can use it as an electrolyte. And with all these together, we can improve the recyclability of batteries and the use of sustainable materials, because we are using a lot of batteries, of supercaps, and at some point we need to recycle these devices. At this moment, this is a problem, this is an issue, as so far recycling those have a higher environmental impact than doing nothing to them, just disposal them. And for those, we need AI to help us planning and implementing these new strategies. We need to reimagine education, reinvent and knowledge them proficiently. We can find rapid technology and societal challenges by using AI, and we need to devote our students to be able to use AI. We need them to accelerate societal, environmental, and economical impacts. And engaging the case studies related to energy and sustainability, we need to gather both. We need to do project-based collaboration with industry and policy actors. And we also need to put students thinking about all the concepts that they are being embedded by sustainability. I bring here a simple example where we could use these plastic, corn-based bioplastics to case batteries, but whatsoever they demand high water, they use fertilizer use, and they are competing with the food supply chain. And in fact, they have limited biodegradability in natural conditions. So it is not because it's bio-based that it's better than the other. You really should be aware of this and be able to question all these new alternatives that are bringing to the table. The key challenges are to assess these properly, to refine the overall sustainability in industry and guide policies, so that we can stream into the production for large-scale implementation and commercialization. Again, this should be cost-effective, because it can be a beautiful concept, but if it's not effective, we cannot go through it. We need to go for costs. We need to find standardization. We need to comply with policies and regulations, especially European Green Deal and Sustainable Development Goals. All of this should be taken in consideration when going from the energy, sustainability, and life cycle analysis of the solutions that I've been presenting around here. We need to measure the impact and the learning outcomes that students are being challenged with. We need to have assessment strategies for system thinking and innovation, and build a long-term students' engagement with energy topics. It's not just because you are doing the course, but it's something that you should implement in the long course of your life. And we need to provide new professionals with holistic problem solving. We cannot think on one matter. We should see the whole picture of the materials for energy storage and for energy as a whole. We need to provide digital literacy and data analytics. collaboration in multidisciplinary teams. We should find balanced GHG reduction with the resource use, and we should include material consumption in energy transition and be aware of life cycle assessment as previously talked in the previous presentation. Digital tools are essential. We need them to roll simulation in virtual labs, gamification to enhance engagement, and platforms for remote collaboration. We will provide online methods, as already taught, and content tailored to diverse audiences to maximize accessibility and impact, meaning from the general public to knowledge community, industry, and policymakers, so that they can make use of the materials that we are providing for their most use. And the project already presented here will answer to these challenges because we want to identify technical areas where these gaps are, and we want to support these gaps and provide solutions by online methods for energy transition and circular economy learning. But we are not alone, because we know that this is a really important topic. There are other projects running, like the Unite Widening, where the goal is to provide mobility between students, also to promote cross-regional learning on sustainability, to strengthen institutional capacity and align educational strategies in European missions. Altogether, we can make the difference. The future directions. We think that the future directions are in integrating circular economy content into energy curriculum, as at this point I think you are already convinced. Fostering international and interdisciplinary cooperation. This is essential. We cannot move forward with this. We are exploring the learning needs. It will be presented in the next presentation. A survey that we got here with almost 500 answers, from which half it's from students. And we need to balance. Environmental and economic impacts are key in educational area. And while AI tools can significantly accelerate the progress, we must be aware how to use it, because we need to be conscious of the interpretation of the AI that the AI will provide us, and it must be settled in pure databases. With this meaning that we should use AI on databases that are scientifically accurate. We cannot use AI on databases that have no reliable information. In the innovative teaching methods for energy transition, energy education must involve interdisciplinary, tech-integrated, and value-driven. I hope to have shown that we are doing this at the University of Lisbon, and that collaboration is essential between academia, but also with industry. We should provide industry with their needs and find new solutions, and policymakers to align education with real-world needs. We cannot dissociate schools from the real-world needs from the future. We need to provide skills like system thinking, digital fluency, sustainability awareness. This must be put it into our students. Our students must be able to think of all of this. And of course, accessible learning, educational tools and contents that must be accessible to a range of audiences that we want to catch. And thank you all for being here and listening to this presentation. This could not be possible without all the partners involved. If you have any questions, please feel free to ask. And I should stop sharing and okay.
Thank you so much for this excellent presentation. I do not see any question on the chat. So I think at this stage we can move on to our next expert, Dr. Selcuk Toprak from the university.
Gebze Technical University.
Thank you. So today I'll be first. I'm from Gebze Technical University. It is located very close to Istanbul in Kocaeli. And today we will be talking about renewable energy and circular economy educational perspectives. So you already heard from our speakers today the importance of the circular economy, energy transition, and we will be covering some of those topics as well. And then I'll be talking about a survey we conducted as part of our project about the educational perspectives and educational gaps and what we can do for the future related to energy transition and circular economy. So we are talking about multiple issues here. When we mention interdisciplinary approach, actually we have to apply this in this particular topic in a more comprehensive way. So we have here climate change. We talk about renewable energy, and there are key types of the renewable energy, and we need to consider all the aspects related to those. And in addition to those, we need to be ready for future trends and future studies, and educational relevance, educational perspective gets into the picture here. So there are different aspects we need to take into consideration, and we start from core principles of circular economy and then continue with sustainable design importance. And then we need to be considering systems teaching. So we need to understand interconnectedness in reducing waste and improving resource use in these different aspects of the circular economy and energy transition. In that way, actually, we need to apply the synergy of renewable energy and circular economy, and we know actually they are interconnected in many ways. So we need to have a reduced reliance on fossil fuels, and then we need to have a combination of renewable energy and circular economy principles that supports the development of products designed for longevity and recyclability, reducing environmental impact. At the same time, we need to take into account enhanced resource efficiency. So we need to ensure that materials are used in optimized way and the waste is minimized, and then we need to contribute to sustainable life. So here, how are we going to incorporate all those in our curricula, and also preparing our students and future engineers, let's say managers, all the users of these techniques, these approaches into their work life. We need to do in our teaching concepts as well. So within that concept, we particularly focus on project-based learning, and here we need to take into account real-world challenges. So basically, we need to, in addition to our concept approach, we need to be relying on hands-on approach as well. And then interdisciplinary approach is a must here, and experimental learning should be focus of this teaching approaches in the future. Well, when we explore educational benefits and challenge what we see, we need to enhance the student engagement, in addition to develop practical skills here, basically for future careers in sustainable industrial, enhancing their employability. And then because there are some complexity or there are some, let's say, unknowns in many ways, we need to be ready for the complexity of sustainability topics. Therefore, the educators be well prepared to effectively teach these subjects as a result of interdisciplinary integration of different various topics. Well, this brings us also the need for updated resources. Here we are talking about since we kind of take pieces from different fields, different sectors, and combine them to have a common objective here. Therefore, we need certainly updated resources to deal with all these different involvements. And then this brings us to different innovative education for sustainability. And for example, Marta mentioned AI approaches in those applications. And we need to incorporate the current technologies, but also I think we need to kind of direct or bring in specific directions about the needs of these particular energy concepts. That requires actually global collaborations, because the issues, the problems, the life cycle approaches, always you deal with them in local concept, but actually the problem is more broad. For example, Krzysztof showed some materials available around the world, and there are a waste of materials in different parts of the world, but in different sections of the world, you need them. And you produce, let's say, significant amount of a particular waste at some locations. Maybe you need to kind of utilize them also in a recycling process. So all of those actually bring us to global collaborations and also to share best practices and resources among ourselves to promote a unified approach to education, which also take us to continuous curriculum development. As we see, there are always different changes in technology that we need to adapt for, and we need to utilize them in our objectives here. Well, as part of this project, we have different work packages which deals with different target groups to reach to a common products useful for everybody, I can say. Here, to achieve that objective, we had a detailed learning need analysis and definition of course design principles. Within that particular work package, we worked with all our partners to define the most current learning needs in different target groups necessary to confront and define all gaps in current curricula in different target groups. So as a result, to get all the current situation and also the opinions from different target groups, we prepared questionnaire, and in that section we asked students, academicians, sector representatives what they think about the state of the art of the teaching, learning in circularity in energy system sectors. So we had some targets. We certainly achieved those, and we started this synergy survey some time ago, and we had sufficient time to reach different target groups in various countries, not only partner countries in this project, but also some participants out of the countries within that project. We got their let's say participation here, and it was a relatively long but a comprehensive survey that we accomplished, and we were able to get the challenges, barriers, and open feedback from those partner participants. Here you can see a summary of the survey participants from different countries, approaching 400 related to this particular topic, and about 212 of them were students. And you can see the distribution here. As you can see, we have contributions from different areas, researchers, let's say managers in the energy power sector, but primarily also from higher education, including graduate and undergraduate students, to get ready for the future objectives, future targets that we want to reach. Well, we got some information about their background here. For example, how many years of experience do they have in the field? So we have a range of participants from less than 1 year to more than 10 years. So that actually gives us opportunity to evaluate different aspects. And the survey showed actually the participant has a different primary area of focus. As we mentioned in the beginning, that covers renewable energy technologies, energy policy, energy storage solutions, circular economy. So actually, we touch on different aspects of this project topics. And in terms of the size of the organizations, we also cover different sizes, less than 10 to more than 250, as you can see in the graph. And the experience also at different levels here, the majority of respondents were affiliated with organizations having less than 10 years of experience, but we also had very experienced participants in that particular survey. And also the familiarity with the concept of energy transition is various among partners. All those background questions actually prepared us for the needs and also this evaluation of responses in various topics. Let's say you see we are covering different topics here. For example, we focused on circular economy principles. Then we continued with material resource management in the context of renewable energy technologies. And then we talked about those different aspects of renewable energy technologies, solar power systems, wind energy systems, hydropower, energy storage technologies, hydrogen energy systems, and we see a good distribution among those. Well, we have also some observations here. For example, the discrepancies suggest that while mainstream renewables are becoming well known, emerging technologies still lack adequate exposure. And that actually bring us introduction of these lesser understood systems with technical depth, real world case studies, and practical application context. Basically, in that approach, we need to think about a comparative technology matrix that could be a helpful educational tool. The course should cover the topics that or the materials that will be developed in Synergy project will cover case-specific cradle-to-grave analysis in terms of life cycle assessments. Also, when we focus on the topics that are discussed in professional or academic setting, brought into the highlight that the need to strengthen integration of underrepresented but critical topics, particularly life cycle impacts in educational and professional dialogue. Well, all or most of the participants particularly believed in those circular economy principles in energy transition education, basically that take us to the particular issue that forward-looking approaches that connects environmental responsibility with technical design has a special importance here. The other important issue was how critical was the understanding rare and valuable material consumption for designing renewable energy systems. And here, real-world supply risk scenarios and trace simulations particularly could enrich this learning outcome. And also, there is a particular demand for education on, let's say, geopolitical dependencies, material and supply chain resilience here. Well, I'm getting close to the close to end of my presentation here. I will skip one or a few slides here, basically to speed up, to use the time effectively. But also we evaluated the courses, that engineering courses that cover particular topics, and we see some deficiencies here. Basically, a modular syllabus should be followed with clear learning outcomes and cross-reference teaching materials. Industry cases and policy brief reviews could add valuable benefit to this particular course. And the most valuable topics here in energy transition course should cover climate charges, for example, circular economy practices in energy systems, technological innovations in renewable energy as well. And hands-on approaches will be very valuable as well. Let me proceed with some of those particular questions because I already mentioned them, but that will, let's say, another topic was cross-disciplinary collaboration. So this particular topic is very or extremely important in many aspects, and we need to encourage collaboration between technical and non-technical students with respect to real-world experience. And also, there are some issues related to what type of training should be followed. For example, case study presentations. I think this has a particular importance here. Problem-solving exercises or instructor-led online workshops. So we see actually a combination of different applications here. Almost everybody prefer case studies because basically you obtain here hands-on experience and basically you reach the real-world examples. And there are, of course, significant challenges here related to material recovery, and which also identified as part of the issues here related to be ready for future challenges and also to assess the viability of circular approaches in different concepts. Well, these are particular critical gaps in the current curriculum for energy transition education. We see those, let's say, lack of emphasis on here material availability, insufficient coverage of life cycle assessments, and that actually brings us to the need what we will be achieving in this particular project. We also ask for the opinion, skills, and tools that should be priorities in education and energy transition and circular economy, for which we had actually type 5 results, for example, case studies, best practices, cradle-to-cradle education, eco-design, application of life cycle programs, training, material flow analysis, databases and high-quality education resources, and softwares and databases that should be prioritized. And there are some already existing applications around the world, but still they are a few, and they need to be developed. That actually why we focused on this particular topic and issue with this project. There are some certain learning needs identified. The first one, fundamental knowledge on circular economy and energy transition that should incorporate economic principles, material life cycle management, importance of sustainable resource management, recycling, and technological innovations. And in terms of technical and policy-related learning needs, we cover material use in power systems, policy and regulations, and the technological gaps like energy storage, hydrogen systems, smart grids, and waste-to-energy solutions. And all these should be compliant in combined in application-oriented and practical learning methods that apply real-world case studies. And lack of cross-disciplinary approach is an issue for the time being that should be handled in the future in the products of that CESynergy project. And barriers to teaching circular economy transition also be handled carefully, because there is a gap here in current teaching methods, and there is inadequate coverage of key topics, and limited practical exposure is another issue that should be handled in the project products in the coming years. So these findings actually indicated an urgent need for an interdisciplinary, practical, and policy inclusive approach in energy transition education. So we propose some particular modules that should be included in online course here. And we have some particular suggested assessment methods. So those modules will be integrated into the modules that Krzysztof already mentioned comprehensively. So these actually particular ones will be integrated into broader topics. And I would like to thank you for your attention, and also I would like to acknowledge my colleagues at Gebze Technical University with whom we were working together, Professor Banu Çetin, Associate Professor Çiğdem Balçık, and our assistant postdoc. Thank you very much.
Thank you so much for this insightful presentation. We have a couple of questions. Some of them I believe are to you. One is related where the participants can find the survey results. Is it something that is going to be shared publicly? I will just maybe list the questions and then we can address them. They are all on the chat. So if you can have a look, this would be also helpful possibly, but I will read them out. So I will start in the chronological order how the questions were asked, but the technical one are related with whether the PowerPoints will be available for participants. So this is to all of you, and about the survey results. Then we have a question about AI use. That AI use has been addressed several times as a supporting tool, while clearly being a source of enormous resource itself. How do you address this challenge in education? This is one. The other one I already mentioned about the survey results. Then we have another one related with, specifically presentation from Professor Pikoń and the numbers. So all the links will work for this person because it's a Polish participant. However, I think it would be beneficial for everybody to have all the presentation. Then we have, I believe, the question to the last presentation. You emphasize the importance of in this interdisciplinary approach. In your opinion, how can we build a meaningful bridge between engineering and social sciences in this context? Then the next one is, you talked about being ready for the future. What topics or courses do you think are essential in today's university curriculum to truly prepare students for this transition? So dear experts, the floor is yours. Maybe we can start answering in the order of presentation. So I will pass the floor to Professor Pikoń, and then we can move on and have inputs from everybody.
Okay, thank you. So we're trying to answer the first question about AI. Well, yeah, it was AI use has been addressed several times. Yeah, so we're trying to answer this question is very interesting because AI is a wonderful tool, but a little bit new tool. And this tool could be extremely productive while making, for instance, optimization of different processes. So for sure, we should include it in curriculum, and we should teach students about it. Actually, if the question was that it is a resources intensive tool, and I must say that this is not a perfect truth, because if we make the comparison of use of AI and the use of Google search, well, AI is using less energy and less resources than the Google. Of course, if we look at the old servers and the whole equipment that is used for AI, and especially for teaching of those language models, this emission is substantial, but if we take into the consideration that it serves for the whole planet, well, as I said, it is estimated because it's very hard to estimate. Just medium length response could generate carbon footprint on the level of 0.1, 0.2 grams of CO2 equivalent, which is quite similar to the one Google search. So yes, we are using resources for AI, but comparing to the old benefits that we could have from implementation of AI, well, this price, this environmental price that we are paying for it is rather low. So I think this is this question, and this is this answer for this question. Anyone would like to add something or?
Yeah, I could probably add something in a different perspective as a teaching. You really need to guide students how to use AI because they cannot trust everything that they have from AI. We need to give them the ability to think about the answers and to know where to look for the information, because using the AI alone blindly, this can be really misleading. So I would add this in a different perspective.
Yes, of course, you're right. It's substantial to know how to use AI. If someone is using it for the creative work, it's completely misleading. But to replace our, let's say, not interesting, repetitive work, AI is perfect. Yeah, that's true. But well, so we should teach students how to use AI. Perfectly.
There is additional question regarding AI, which I think was triggered by your exchange. Is there also calculated data on it, I mean AI, or an assumption for AI benefits?
Yeah, well, it's a huge problem to make such evaluation. So the data that I have plotted is a rough estimation. It's just to show the level of. But it would be very interesting to make such evaluation. But we must understand that to calculate potential benefits and also externalities related to solutions elaborated with AI, because as we said, we should not treat AI as a separate person that is solving something. It should be treated as an assistant for the human in solving something. To make such an evaluation, it is extremely hard, and honestly, I haven't noticed so far any reliable research on that, detailed research. So we could talk about the rough estimations which are available, but of course, this is a good topic for the future.
Professor Toprak, would you like to react to the same topic or maybe address the other questions?
Yes, I want to make a few comments also. The users of AI is aware that the primary issue with AI is at the moment is training of AI. So he is very fast to integrate the information, let's say, to make the comparisons and to do many achievements in that respect. But when you get the particular questions, particular topics, basically fundamentally, if he gets the best information or best training, then he can answer, or it can answer your questions or your request quite efficiently. So I think in the future, with the addition of more information to AI system, it can be used more effectively. But at the moment, like human beings, we are also trained. It is also trained with different information coming from different sources. So, for example, how reliable those sources become important as well, because it is presenting a kind of summary or a combination integration of those informations already provided to it. So in the future, we will see quite a bit of advancement in that aspect too. So it will be, let's say, especially if you want to develop new information or new, let's say, methodologies, new techniques, etc. This will be combined with the technological advancement, but also with the training of these systems. Basically, I would like to take attention to that point as well.
Mhm.
Okay, thank you so much. We also have the question about the topics that being ready for the future. What topics or courses do you think are essential in today's university curriculum to truly prepare students for this transition?
Actually, this is the objective of our project to name such a courses. But of course, we have already identified the areas that we should deal with. And the type of implementation. For sure, we should implement something interdisciplinary. And as Marta mentioned, those social sciences, environmental, social, and economic. This connection is very important for a better understanding of the current issues. Interdisciplinary curriculum, but also this connection of circular economy and energy transition for sure. So this material side. And additionally, we should be also focused on a challenge-based learning. We should think not only about what fields that will be covered by those courses, but also how those courses would be delivered. And based on this survey and other activities that are planned in our project, at the end of the day, we'll have such a list of not only courses but also nuggets inside those courses that should be addressed to deliver the best result.
If I can add something, there's a new trend now in European Union Commission that you really need to try to engage with social sciences in the sense that you can develop good science, but if you don't have people engaged, they will not consume the final product that you are producing. So picking up on an example that I provided in my presentation, if you are developing batteries based on the disposals of cork, the people that are used to collect cork and that population from there will probably more easy to buy a battery made of cork. So this overview thinking and integration of the different areas, it's really important to make all the engagement and to make your final product viable and have acceptance.
Thank you so much. And if you can have briefly from Professor Toprak the input, because we kind of arrived to the end of our time here.
Well, when we talk about circular economy and energy transition, it is not only a technological aspect that we need to deal with. Actually, there are also, let's say, human reaction, collaborative participation, and political approaches. So there are many aspects to these processes, which involves also social sciences. Actually, it kind of forces all of us in technological fields and social sciences to work together to have a better world, to use our sources effectively, to make a transition smoothly in many aspects. So we need to bring together those experiences to kind of reach more people around the world and to teach more people about these concepts. It is a must for us.
Thank you so much. We didn't manage to address all the questions, but this is not the end yet. The project has just entered its main phase. And I have shared with all of you on the chat the link to our website. Please follow us on social media. And for the very last question that is directed to Professor Toprak, I think we can try to address it by email. So thank you so much for this meeting. Thank you so much, all the experts. And we will stay in touch with participants following up on the outstanding issues. Thank you.
Thank you.
Thank you very much.
Thank you.